This method can help answer key questions in the field of shellfish ecology, such as how much cestin are available as high-quality food at potential aquaculture sites.
The main advantage of this technique is that it is much more reliable than laboratory experiments because the measurements are conducted within the natural environment.
This method can be applied to other systems and species, as well as can be expanded to understand the ecosystem services provided by shellfish.
Individuals new to this method will struggle because the conditions at sea can make sampling challenging, either through boat movement or the lack of food availability for shellfish.
Visual demonstration of this method is critical because every step, especially the sequencing, needs to be done correctly to get a valid measurement.
While still at the dock, assemble the gimbal table to consist of 2 frames, a gimbal table and a ballast tank. Stock a PVC cube with a removable ballast, and fill the ballast tank with 85 kilograms of seawater. Insert a 50 kilogram zinc weight to the bottom of the ballast to act as a counterweight to the swing of the table, and attach the ballast tank to the gimbal table. Place a 50 millimeter long T-shaped movable baffle piece on top of the feeding chamber walls for water to flow under within the chamber 1 to 2 centimeters in front of the bivalve. Fit the head chamber and feeding device on top of the gimbal table and hold the materials in place with anti-skid mats. Then, start the pump to allow the addition of seawater to the device from the appropriate experimental depth. To calibrate the flow rates,